Common-emitter common source amplifier with complementary load. A common-emitter amplifier with PNP current mirror load is shown in Figure 4.16a. The common source counterpart with a P-channel MOS current mirror load is shown in Figure 4.16b. In both cases, there are two output variables, the output voltage, V out, and the output current, I out. The relationship between these variables is governed by both the input transistor and the load transistor. From the standpoint of the input transistor T1, I out equals IC1 or I out equals ID1, and V out equals VCE1 or V out equals VDS1. Equations 4.113 and 4.114 show that the output I through V characteristics of T1 can be used directly in the analysis of the relationship between the output variables, since the input voltage is the base-emitter voltage of T1 in Figure 4.16a and the gate source voltage of T1 in Figure 4.16b. The input voltage is the parameter that determines the particular curve in the family of output characteristics under consideration at any point as shown in Figure 4.17a. In contrast, the base-emitter or gate source voltage of the load transistor T2 is fixed by diode-connected transistor T3. Therefore, only one curve in the family of output I through V characteristics need to be considered for the load transistor, as shown in Figure 4.17b, from the standpoint of the load transistor. I out equals negative I C2 or I out equals negative ID2, and V out equals VCC plus VCE2 or V out equals VDD plus VDS2. Equation 4.115 shows that the output characteristic of the load transistor should be mirrored along the horizontal axis to plot in the same quadrant as the output characteristics of the input transistor. Equation 4.116 shows that the load curve should be shifted to the right by an amount equal to the power supply voltage. We now consider the DC transfer characteristic of the circuits. Initially, assume the VI equals 0. Then the input transistor is turned off and the load is saturated in the bipolar case and linear in the MOS case, corresponding to point 1 in Figure 4.17c. As Vi is increased, the input transistor eventually begins to conduct current, but the load remains saturated or linear until point 2 is reached. Here the load enters the active region and a small further increase in Vi moves the operating point through point 3 to point 4, where the input transistor saturates in the bipolar case or enters the linear region in the MOS case. The range in Vi required to move from point 2 to point 4 is small, but because the slopes of output I through V characteristics in the active region are small for both transistors, the transfer curve, V out, as a function of Vi, is sketched in Figure 4.17d.